The optical properties of materials impact various aspects such as appearance, visual effects, and optical functions, which are essential inputs for optical simulations and visual effects simulations. For example, vehicles have evolved from simple vehicles into intelligent terminals, and there are some features such as head-up display, vehicle display, automotive lighting, and rich interior designs for intelligent cockpits which can make lighting environments inside the vehicle complex and diverse. Optical simulation designs for each components and visual effects simulations require the optical property parameters of relevant materials. The spatial transmission and reflection characteristics are key optical properties and can be represented by BSDF. For instance, the transmittance and haze of the two samples are very similar when tested by HAM300. However, they are significantly different in practical applications. In such cases, the differences cannot be simply evaluated based on haze from large-angle scattering or total transmittance, but the spatial transmittance characteristic analysis is necessary. For BSDF distribution under the same zero-degree incidence conditions, the transmittance ratio of the materials is close in the large-angle range, but there are big differences in the small-angle range, and also the clarity is impacted. So it's necessary to measure BSDF for materials in various incident conditions to simulate the results under different and complex lighting environments. Everfine BBMS-3000 is a spatial BRDF BTDF testing system specifically designed for the analysis of spatial reflection and transmission, which adopts a uniquely designed laser light source that can be adapted to different sample tests by customized laser wavelength. Additionally, the system adopts a four-dimensional turntable, enabling comprehensive spatial testing for both reflection and transmission properties, making it highly suitable for the analysis of isotropic and anisotropic materials, and the test of spatial scattering in highly specular and transmission materials with high spatial resolution and dynamic range. It's worth noting that BBMS-3000 is equipped with powerful software to intuitively and rapidly compare and analyze the sample characteristics besides measure BSDF. It allows for the 2D profile distribution can be flexibly switched to view the BSDF distribution at various azimuth angles, facilitating direct comparisons of the maximum values and scattering angles for specular samples. 3D polar coordinate distribution provides an intuitive way to visualize the spatial BSDF distribution, making it particularly useful for assessing the scattering characteristics of diffusive samples. 2D polar coordinate plot is suitable for the analysis of the BSDF of special samples, which can clearly reveal the spatial distribution characteristics of microstructured samples. The software supports TIS calculations and can provide real-time updates based on different settings. What's more, the software also supports reflection analysis, including specular reflection, specular exclusion, and haze analysis, as well as the calculation and analysis of transmission parameters like direct transmittance, haze, and clarity. The data obtained from BBMS-3000 testing can be imported into optical design software such as LightTools, SPIOS, Tracepro, and Zemax, which can assign the BSDF distribution to material surface properties for further simulation and modeling. Everfine BBMS BRDF BTDF measurement system has been widely applied in fields such as automobile, aerospace, aviation, flat panel displays and lighting thanks to its exceptional performance.